Last week we started this handout and you were assigned problems 1 through 8. So if you were absent on Thursday, please get a copy of the handout from your teacher. Problem number 1 has already been completed, again because we discussed this problem in class last week. So for those of you that were not there, when writing congruent statements, based on the markings here, angles P and D are marked the same, Q and E, R and F are also marked the same. That would be the red statements here. And then in terms of segments, PQDE, QREF, PR, and DF are also marked the same. And then the two triangles are congruent to each other, based again on all the information. We discussed about angle measurements. Sometimes an angle can be labeled with one letter, sometimes with multiple letters, as in 3 letters. The way that we decide that based on chapter 1 of your textbook is if I would look at all the angles at a single vertex. We only name angles that are less than 180 degrees or smaller than a straight angle. At point Q there are 2 angles. There is the red angle that I just drew, which is called a reflex angle, which is over 180, less than a circle. And then the angle inside the triangle, that angle is acute. So since there is only one angle less than 180, angle Q can be labeled with just a single letter. I gave an example very similar to this on Thursday. If I would label the points, let's say A here on this segment, so I label this point here B, for example, C at the point of intersection, D, let's say D is here, and point E is here. And if I would say to you, I'm thinking about angle C, would you know which angle C I'm talking about? Because there actually are 4 angles at point C. This is an example where for the angles that are at point C, those 4 angles are all under 180, and so these angles, each of these angles would require 3 letters to make sure that we're talking about, let's say, the angle here at the top, which is angle ACD, or this angle down at the bottom is angle BCE. So that's again just kind of a reminder. So starting with problem number 2, you were 2 through 8 should be finished if you were here last Thursday. If you were not, I'm going to go through the problems. I would recommend turning the video off at different times and work on the problems. You will need a ruler here potentially if you want to draw a segment, and that's fine. Patty paper, if you need to check something, patty paper's on the metal cabinet. So again, those are the tools that are available to you. So problem number 2 is asking you to identify which shapes are congruent by dividing the shape up, and then on problem 3 they're asking you to write a congruent statement. So if you haven't done this problem, go ahead and do this, and then turn the video back on when you're ready to continue. Alright, so there are 3 ways of actually doing this problem. I'm just going to show you one. So if I would just draw a line something to connect points A and B, this quadrilateral here and this quadrilateral here are congruent. And if I would connect points M and R, I could actually create 2 rectangles that are congruent. If I would, where my cursor was right now, approximately right there, I could rotate the shape 180 degrees, or I could take the shape and I could slide it also to get the show the triangles or the rectangles are congruent. So in terms of a congruence statement, anytime we have more than 4 or more points, we don't put a special symbol in front of it. We do that for triangles because we also label angles with 3 letters. So angle A here and angle B down here would be the same, would be the corresponding angles if I would rotate the shape 180 degrees around this point here. Angle G, which is a reflex angle, and angle F would also be the corresponding angles. Angle Z would be same as D, and then E would match up with L. So the shape, A, E, GZ is congruent. So again, angle A matched up with B, angle E matched up with L, G matched up with F, and Z matched up with D. In this shape here, I'm going to do like a translation slide. So I have R, S, J, and K. You'll notice I didn't list all letters on that. On the edges of the rectangle, I did not mention point M, because point M, although it isn't on the segment, it's not a vertex. Alright, so if I slide this for a congruent statement, angle point R will match up with point P. Those will be the corresponding angles. S would match up with Q. J would match up with M. And K would match up with N. And this last letter here, where I said M, I was talking about M. This is not M, it's K. So again, keep in mind that we do not list points that are on the segment as a letter on the shape. Only vertices are used as letters for the name of the shape. Right. Problem 4, I've already started it. We're supposed to do a rotation. Again, this is where shape pad paper comes in at. So this is what the shape looks like, and then you're supposed to, problem number 5, supposed to decide what kind of shape is it, and then what's the sum of the 4 angles of that quadrilateral. Problem 6 is asking you to superimpose triangle ABC onto DEF. What transformation did you use? Problem 7 is asking you to complete the congruent statement, and then problem 8 is asking you to kind of justify it by the superimposing piece. So again, if you've not completed the problems, I'd recommend going back and doing that before you continue with the video. So in problem 5, they're asking you to identify what quadrilateral we have. So if I would begin at the bottom with a square, this is not a square because the fact there's not 4 equal sides. Also, the angles are not marked as a right angle. This angle here looks like it's obtuse. So some of the issues. Rhombus, again, this is not a rhombus because we don't have 4 equal sides. Rectangles, again, it'd be real hard to prove that angle C, those two pieces add up to 9 degrees. Again, this angle looks like it's obtuse. Continue with parallelogram. Two sets of parallel sides. That might be something we could check on. Kite, the sides that are next to each other have to be the same, and the sides next to each other are not the same. Trapezoid. If you're doing an isosceles trapezoid, we have to have a set of equal sides for the isosceles trapezoid, but the other side has to be different. So this can't be a trapezoid by definition because the set of parallel sides have to be a different length. So this is either a parallelogram or it's just simply a generic rectangle. So one of the statements I made to begin back in the second 9 weeks, and probably the first 9 weeks as well. If you have a parallel line, if there's potential parallel lines, if you draw in a Z, which are the two sides that are parallel, and the side that's called the transversal, the angles created at that point, which is that Z, those are called alternate interior angles, and they're both marked the same, double arc. So that means that based on alternate interior angles, those two angles are the same. If I would go the other way, which would be this segment here along this transversal, and then back this direction here, this angle here, and this angle here, which is part of the Z, they're also marked the same. So again, anytime I have alternate interior angles, I'm looking I'm going to be drawing in a letter Z, and if the two angles being created in that Z, if those two angles are the same, which again, those are called alternate interior angles, then the segments themselves have to be parallel. So that's kind of our test. And you're going to probably find more often than not, with quadrilateral, you're going to be checking alternate interior angles. So both of the sides are parallel. So in problem number 5, the special shape we have here is a parallelogram. It has two, by definition, it has two sets of parallel sides. What's the sum of the angles of the quadrilateral? I hope you decided it was 360. And the reason why is because you have two triangles. And both triangles, the three angles are being used to make the angles of the quadrilateral. So since the triangle angle sum is 180 degrees, and all the angles are being used as angles of the quadrilateral, then the sum of the angles would be 360 degrees. Alright, so for problem number 6, superimposing means I'm going to take the shape, I'm going to do something to it, place it perfectly on top of the other shape, and so all the corresponding angles line up, all the corresponding sides line up. So in this problem here, for these two triangles to be congruent, I'm going to slide this triangle from point E to point E, from point B to point E, same thing from A to D and C to F. So the transformation I would be doing is called a translation. Alright, on to the next problem. It says complete the congruent statement. Does the order of letters matter? And the answer is yes, because when we are writing congruent statements, we want to make sure that corresponding parts match. So this transformation actually is a reflection. So somewhere in here, there's a line of reflection. So point B, for example, and point E would fall on top of each other. Point A, because of the reflection, and point F would fall on top of each other. And point C and D would match on top of each other. So it's the line of reflection is what's being used here to get the triangles to line up. So let's just call it superimposing. So angle A matches up with F, B matches up with E, and C matches up with D. So starting with problem 9 to the end, this is the problems that were not assigned. And I'd like you to complete this activity. We will talk about this one on Thursday. You should plenty of time to finish this up in class. In problem number 9, 3 triangles at the bottom, or on the last page, they are all showing side angle. And one of the reasons why side angle doesn't get used as a congruence pattern is because it's possible to have two different triangles with the same information. So they're asking here is which of these triangles here, which of these two triangles here is congruent to ABC. And so I suspect that in this problem here that those two triangles are each of the possibilities, and only one of them actually will line up or match triangle ABC. So complete this and then move on to the next activity, which is on triangle congruence.